So welcome all. In our last lesson, we began what we called calculus. And I believe that most of you are able to get the notes, even those who are not there. And those who are in the physical class, I think in the last class, we had agreed that the QA lessons will be online. Because most of us are able to do it online. Yeah. So today, we just proceed with our discussion on calculus. And we want to begin, or I want us to look at something known as differentiation. 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 That is what we are going to discuss today. So you write the following. Differentiation is a branch of calculus. Differentiation is a branch of calculus which involves determining the rate of change. The rate of change for a non-linear function, which involves determining the rate of change for a non-linear function. Full stop. The rate of change is known as gradient. The rate of change is known as gradient. Full stop. Differentiation is therefore said to be a technique. Is therefore said to be a technique used to determine the gradient. Used to determine the gradient for non-linear functions. Used to determine the gradient for non-linear functions. We'll stop. A function is differentiated. A function is differentiated with respect to its independent variable. A function is differentiated with respect to its independent variable or variables. Respect okay, that's okay, Benita. A function is differentiated with respect to its independent variable or variables. First off, the result of differentiation is known as derivative. Known as derivative or differential. Which is written as dy dx all f of y with an apostrophe there. That's how it is written. Which is written as dy dx. Then we write that there are various rules that are used. There are various rules that are used in differentiation. There are various rules that are used in differentiation. Full stop. In applying these rules, the following rows of indices, are applicable. The following rows of indices are applicable. Number one, if you are given a number written raised by 1, it is that number that way. Number two, if you are given a number raised by 0, it is 1. Number three, if you are given 1 out of a number, it is that number raised power minus 1. If you are given a number raised power m multiplied by a number raised power n, it is that number, you get m, you add n, you get m, you add n. And if you are given a number a raised power m divided by a raised power n, it is that number m u minus n. So those rules are very, very important. The rules of indices. The rules of indices. Okay, so I believe you have finished to copy. So let's begin with the first one. I believe you have copied. So number one, I call it constant rule. Constant rule. Constant rule. And you write that a constant is an element in a function, that does not have, an element in a function that does not have the independent variable as a coefficient. That does not have the independent variable as a coefficient. Full stop. The rate of change of a constant is 0. The rate of change of a constant is 0. Okay, so if you have an example whereby you are told y is equals to 8, dy dx is 0. Dy dx is 0. That is because That is because this one does not have x. So that is called the constant rule. Let's go to the next one. Let's go to the next one, which is called general rule. Right here. General rule. General rule. And we write that these rules require, this rule requires the following two steps to be taken. This rule requires the following two steps to be taken when differentiating a function. When differentiating a function. Roman 1. Multiply the function. Multiply the function by the original power. Multiply the function by the original power. Step number 2. Step number 2 is subtract 1 from the original power. Subtract 1 from the original power. Subtract 1 from the original power. Okay, so let's have an example. Example 1. Example 1. If you are given y is equal to 3, rather is equal to x raised to power 4. If you are given y is equal to x raised to power 4, dy dx. The first step is to multiply this function by the original power, 4. So you take 4, then you multiply x here, raised to power 4. That is the first step. You multiply the function by the original power. Then you subtract 1 from the original power. When you do that, the answer that you get will be 4x raised to power 3. Will be 4x raised to power 3. Example 2. Example 2. If you are given y is equals to 7x raised to power minus 2. If you are given a function like that, y is equal to 7x raised to power minus 2. Then you will have dy dx. So tumesema you first of all take, there you're not seeing my board. So you first of all, y dx, you first of all take the original power, which is minus 2. Then you use it to multiply the function 7x raised to power minus 2. That way. Then you reduce this by 1. You reduce that by 1. So the final result This will be minus 14. Minus 14 x raised to power minus 3. Minus 14 x raised to power minus 3. If I gave you another example, example 3. Example 3, if we are told y is equals to 5 out of x raised to power 4. Y is equals to 5 out of x raised to power 4. Now this is the same thing as 5 x raised to power minus 4. Going by the rules of indices that we did show. Now, when you say dy dx, it is going to be, you take the original power minus 4. Then you multiply by this function, 5x raised to power minus 4. Then you subtract 1. And the answer will be minus 20x raised to power minus 5. Let's discuss rule number 3. Rule number 3 is called addition and subtraction rule. Addition and subtraction rule. Addition and subtraction rule. And this one states like this. If y is equals to u plus v, if y is equals u plus v, where both u and v, where both u and v are functions of x, then actually let's come back here and say plus or minus, because I'm combining plus or minus. Then dy dx will be du dx plus or minus dv dx. In other words, you just differentiate each on its own. So if we have example 1, you are told y is equals to x raised to power 4 minus x raised to power 3 plus 7. You are given something like that. So these are the u's and v's. I've given you 2 here, u and v, but that does not mean the function has only 2 elements, can have more than 2. So these 2 are just representative of the others. Sasa, dy dx, it means you take this one, you differentiate kawaida, That is 4 x raised power 4. When you multiply, then you reduce by 1 that way. Kawaida tu venye tumefanya kwa general rule. Then ukuje kwa huyu mwingine useme minus, take the original power 3, then useme x raised power 3. We have multiplied. Then you less by 1. Then you say plus, come to this one, 7. Now this 7, it is like 7x raised power 0. 7x raised power 0. So you take 0, then you tell us this 7 is the same thing as 7x raised power 0. Then you subtract 1 here. Subtract 1. So this settles as this times this is 4x raised power 3 minus 3x squared plus 0. Remember, in our constant rule, we have said that the differential of a constant is 0. The differential of a constant is 0. That's why you're getting it there. That one is as simple as that. Let's go to the next one. Number 4, which is called product rule. I think I can still write it up here. Number 4, product rule. Product rule. So product rule is stated like this. If y is equals to u times v. Someone has written a message, let me look at it. But you can copy out that point. Oh, Hilary is asking whether we can put the plus 0 hapa or we ignore. Either way, you can put it or you can ignore. Either way will work, Hilary. So we are saying if y is equals to u times v, where both u and v are functions of x, then dy dx will be u multiplied by dv dx. dv dx plus v multiplied by du dx. U dv dx plus v du dx. So let us have an example. An example. So in the example, if you are told that y is equals to 2x squared plus 6, you multiply by x raised power 7 minus 10x minus 10x. That is what you are given. We say let u to be 2x squared plus x plus 6 V to be x7 minus 10x. Then du dx. We now differentiate this function with respect to x. Kawaida, leta hii power hapa, unasema 2, haya 2x squared, you subtract 1. You can see the general rule is very, very much applicable. Haya plus, hii 6 tumesema ni kama 6 raised to power 0, x raised to 6x raised to power 0, so it is 0. 6x raised to power 0, you subtract 1. You subtract 1. 6x raised to power 0, you subtract 1. So this one will remain as manilete hapa chini. Will remain as 4x raised to power 1 plus 0. 4x raised to power 1. Now, as Hilary was asking, this one we can choose to write it or we omit it. This one we can choose to show the one, ama we omit it. So this one we can as well see imebaki 4x. So those are the possibilities. Imebaki 4x. Aya, let us come now to dv dx. dv dx. If you are differentiating this one with respect to x, you take the 7, then you have x raised to power 7, you subtract 1, minus this 10 is raised to power 1, the x is raised to power 1, so it is 1, 10x raised to power 1. So I minus 1. So I minus 1. So when I minus 1, this one comes 7x raised to power 6 minus 10x raised to power 0. We already have said that the number raised to power 0 is 1. So this becomes 7x raised to power 6 minus 10 times 1. Wait a minute, I respond to this call. Hello? Hello to you. Okay, sorry for that. So I was saying this x raised power 0, it becomes 1. And we know any number multiplied by 1 is that number. So this now is left as 7x raised power 6 minus 10. So if we go to our rule, the rule product, okay, Benedict. So the rule now will be dy dx will be u multiplied by dv dx. U multiplied by dv dx. Then you say plus v du dx. That is the rule that we had stated. Sasa, you now substitute the values. So unachukua u yetu ni hii. This is our u. That is 2x squared plus 6. You multiply by dv dx. dv dx tumepata hii 7x raised power 6 minus 10. Minus 10. Plus v. Our v is this one. X raised power 7. Minus 10x. That is our v. Now you multiply by du dx. Du dx tulipata hii 4x. That is what we got. So here utaiacha tu hivyo, don't simplify. When we start now the applications, the past paper questions, we shall be simplifying in case we come across it. So that is how we deal with the product rule. Okay, let us go now to the next rule. Let us go to the next rule. The next rule which is called quotient. Quotient stroke division rule. Quotient stroke division rule. So in this one, we normally write like this. If y is equals to u divided by v, where both u and v are functions of x, then dy dx, is given as v du dx, u minus u dv dx. All these you divide by v squared. That is the quotient rule. That is the quotient rule. Now in this one, you have been given an example. You have been given an example which is y is equals to x raised power 5 minus 7x cubed. You divide by 2x raised power 4 plus 16x. We are given something like that. You say, let u to be x raised power 5 minus 7x cubed. V to be 2x raised power 4 plus 16x. Now, you say then du dx. Du dx. You take the power 5 here. You say x raised power 5, you minus 1. Then you say minus 7. X raised power 3, you minus 1. Minus 1. So this translates to 5x raised power 4 minus 7x raised power 2. Is equals to 5x raised power 4 minus 7x raised power 2. Higher. dv dx will be equal to, this is 2 cos. Sorry, I've made a mistake here. This is supposed to be 3. Rectify is supposed to be 3 and 7 here. I omitted that. This is 3. So the answer, I should get 21 here. I should get 21. Sasa nikikuja hapa nitasema ni 4. The power is 4. This one, 4. 2x raised power 4 minus 1 plus 1, 16x raised power 1 minus 1. When you get logged out, you log in immediately. So this becomes 8x raised power 3 plus 16x raised power 0. And this is 8x cubed plus 16. You log in immediately once you're logged out.